use cases, what are the impact areas, what is holding us back, right? So I think that's the format of the session we are looking at. I'm going to request each of our speakers to maybe give a short 4 to 5 minute perspective on each of their unique areas. And then, we'll do a set of questions, which we'd love to get more from the audience. But if you think, there aren't any questions, I of course have my own set of questions. So let's get into it. Ritu, I think, I want to start with you. Ritu Mehrotra is the founder of Shunya Labs. They are a voice AI startup company that's doing some very amazing work. So Ritu, tell us a little bit about why voice is so important from the whole deep tech transformation space, particularly for enterprises, for government. Where do you think we are making a difference?
Thank you, Sangeeta. And hi, everyone. So the reason we started Shunya Labs was very basic. We are not tuned to be typing. That's not how the human interface works. Our natural way of communicating is by conversation. And that is the first piece. But conversations are extremely complex. So if you drive from just where we are, any direction 100 kilometers, the dialect will change, the language will change, the accent will change. Therefore, for us to solve a problem which the AI, for it to understand the languages that a country speaks, language understanding with emotion, language understanding with sentiments that we use. And that was the premise that which Shunya Lab was started. We wanted to create an AI interface, and we have created an AI interface that talks or understands 220 languages. And not just languages, I'm talking about emotions and dialects along with it, and sentiments and intent. We are a company that is building on frontier models, right? So we build our own models, and our models range between 16 million parameters that can go up to 1.2, 1.3 million parameters. What this means is you can run a voice inference, which means on the compute of my phone, I can actually tell AI that, hey, I am looking for, the X place, and if you can help me guide, right? Because in our country especially, not every place has the right amount of internet. So how do you run those things on edge? The third thing is that we make sure that sovereign AI has taken the forefront, right? We do not want, and just to give an example, as Sangeeta was saying, we are working with government so that, whatever conversations are happening inside some very critical industries like defense, like foreign affairs, like finance, even in private sector, those things we don't share in form of tokens with, companies outside. So therefore, what we are building is a complete voice infrastructure, which has the largest linguistic capability that works on prem, on edge, works on APIs, with internet, without internet. So that's what we're building. Sangeeta.
Wonderful. So you're not just thinking about, the standard infrastructure, but really voice AI infrastructure that can work in very low resource settings also. So that's really a use case from what we heard in the last session about gram panchayats and how they're using technology. I think this coupled with, the adoption that we are seeing at the last mile can play a phenomenal role. Ravi, if I can move to you, just to introduce Ravi Kumar Kappagantu. He's the data and AI architecture lead at the Lloyds Technology Center in India. He's a distinguished engineer, has a number of patents in his name. So Ravi, tell us about financial services and how are you seeing deep technology reimagine financial services? Because that's been one sector that's always been at the front end of, anything new that's come up. How are you seeing the shifts that's there?
Thank you. That is a great question, Sangeeta. And good evening, everyone. Yeah, so before I answer that question, let me take a little bit into historical context for 1 minute, right? So again, 20, 25 years back, when computers came into India and like into our banks, right? So they said that, okay, we have data that is sitting in ledgers, in paper, right? Like we go open a book, write something, right? Like whenever a transaction is to happen, from there, it went into, okay, the data can be digitized, right? So the first segment was digitization. Then we said, like, okay, there is data. Let us use the data to automate workflows, right? So whether it is me drawing money, or like me making a payment, or like me going to a website, doing mobile banking. So anything that is transactional, right, is digitalized. So whether you call it as like a web application or a WhatsApp messaging or a mobile application. Now, right, like we are at the frontier with AI. What are we digitalizing, right? So from where we are, to me, right, like the thing that comes to mind is we are digitalizing trust. So what does that mean? So we are taking the ability to reason, the ability to believe, the ability to autonomously make a transaction. We are giving that to agent, right? So essentially we are digitalizing trust. And what that means is we are going from, hey, right, like, okay, if I have to change an address, okay, I have a document, I download the document, I upload the document to some other website. From there, we are going to, okay, I have a document with a trusted source. I just use that event and I go to the next workflow, right? So essentially the friction that is between departments, the friction that is between processes is reducing a lot, and AI can take a long way, right? Like in that journey. So the second part is the Adjunct technologies. So again, when you have to believe in data, right, like you have to have centralized and trusted data. That is where like another emerging technology that we talk about, distributed ledger technology or DLT, can be very, very useful. So essentially a combination of these two, right, like DLT, AI, and right, like in future as we see, right, like more of quantum, right? So these are all the emerging technologies. They are coming together to solve the next generation problem. And again, they are digitalizing trust.
Thank you so much, Ravi. Digitalizing trust, I think, is one of the hardest problems to address as we get into this whole AI-driven or deep tech-driven world, right? If I can move to Dr. Dhinakaran, he's the country manager for IBM for all the quantum initiatives. He's also the adjunct professor for IIT Madras. Dina, we've heard a lot about AI and what AI can do and the different verticals or specializations in AI. But talk to a little bit about how do you see quantum technologies progressing and where do you think India can really play a role?
Yeah, thanks, Sangeeta, for the question. And maybe I'll just start by polling the audience on who here has heard about quantum computing. Okay, that's sort of, let's say, half the audience, right? So the message I would want to you guys to take home today around quantum computing is you can think of it very similar to how AI was around 15 years ago, or at least the current generation of AI. By that, what I mean is that there are some problem statements that are scientifically important, for which quantum computers of today can beat the performance of any classical computer that exists, like sort of supercomputers that exist, right? So that's the stage we are in today, right? We are not talking about 10 years from now, 15 years from now, or science fiction, right? This is something that we have as of today. And the good thing is also that since the technology is up and coming, you can have access to it through cloud. Any of you can just like spin up a cloud instance and understand like where the technology is. So that's sort of the main message I want you guys to take home today. Now, sort of directly addressing Sangeeta's question about like where we see the use of quantum computers. The initial use will be in the industries and processes where we simulate something related to nature, right? Because quantum computing, or in general quantum mechanics, is not some fiction, okay? It is how really nature behaves. It's how we sort of believe that nature processes follow, right? And we have had quantum-based technologies all around us. Let's say the solar panels we have, the lasers, the LED screens. These are all fundamentally using the theory of quantum mechanics, like fundamentally using that to be used in the real world at a very wide scale. The only thing we are trying to do right now is to build a general purpose computing device based on the same principles. So the initial industries that will be disrupted are those that primarily rely on nature processes, but they have relied on some approximate ways of simulating them. Let's say studying, let's say the properties of vaccines or different chemicals in different industries. So where you simulate the properties of something natural, right? That's the kind of places where we see something like more usefulness. And given the nature of how we can encode data and process it, there are also a lot of optimization problems for which quantum computers have been showing a lot of promise, right? Maybe in the next rounds I could give some potential examples, but essentially these are sort of the broad stroke types of applications where we see the power of this new type of computing device that we are building using quantum mechanical principles. And of course, these naturally you will see them used in governance as well, right? Optimization is sort of a core problem, especially for India scale. So yeah, I think that's where we are at, and we are looking it's literally really promising in terms of what can achieve in the near future.
Thank you so much for helping us understand quantum computing in very, very simple terms. Parminder, if I can come to you. Parminder Singh is the Vice President at Kyndryl India. He's been a strong policy building India market from a technology lens person. He's attended a lot of the national e-governance conferences over the years and seen how these topics have changed from year to year. Parminder, maybe if you could cover your thoughts on how do you think about the deep tech infrastructure and governance of, what India should be doing from an implementation perspective.
Thank you. Good evening, everyone. It's been a long day for all of us. I want to start by, talking about the organization I represent. I represent an organization by the name Kyndryl. We are a spin-off from IBM. We spin off about 4 years back. So we are a 4 years young organization, but we are also $15 billion in revenues. We are listed in New York Stock Exchange. And what do? We run mission critical systems. We deploy tech services, so banking and financial services, airports, Noida International Airport, Bangalore International Airport. We run CBDT, the entire network behind CBDT. We run manufacturing systems, so all the mission critical systems. Interesting, you mentioned about the deep tech infrastructure. I think, since morning, there's been a lot of talk about deep tech in different shapes and forms. I think there are three lenses from which we could look at as this story unfolds. The first lens from which we want to look at is from the trust lens. The second lens is how ready we are for deep tech. And the third lens is how do we manage risk when it comes to deep tech. So the first lens, which is around trust, I want to also talk about, let's say, the digital public infrastructure, DPI. If you look at, why DPI succeeded in the country was because we built trust very intentionally. We didn't assume that, look, oh, UPI will be there. I would transfer some money, from one person to another person, the transfer would happen. We didn't say, look, the trust will come by itself. We literally designed trust, and we said there has to be explainability when that transaction happens. And it is very transparent, so that if you look at it, you see the same transaction. If I look at it, I see the same transaction, and hence it can be explained. Now, when we are implementing deep tech, and which are different technologies, I think one, it has to be very, very transparent, and it has all the decisions that are being taken through deep tech. They have to be very explainable and governable. And so I think that's the first part through which trust will come through. The second part around deep tech also is inclusiveness. If you look at a lot of decisions that we take, when the government takes decisions, for instance, public sector lending, there are certain underprivileged sections to which the lending is made very intentionally. So inclusion is very intentional. But the moment deep tech talks about efficiency, there is a bias that could come in deep tech systems that would say, look, because of efficiency, let's only focus on the sections of population which are great in technology, which are technology enabled, and hence leave those, who are not that fast enough, or who are not that, who don't have that capability right now. I think the third part is also around being open. I think it's very important. If you look at all the parts of DPI that got built, whether it's UPI, digital payments, Aadhaar, different components of DPIs were open. But as we are implementing deep tech, it shouldn't happen that, look, there are silos which are closed, and these become black boxes, and the interoperability is not there. So I think that becomes very, very important for trusted. I want to spend a minute about how ready we are. There is often this misconception that, look, deep tech is a layer, whatever is the underlying infrastructure, you put a deep tech layer on top of it, and then it would solve a lot of your problems. Actually, it's the opposite. Deep tech exposes all the gaps that are there in the system which were not visible earlier. For example, right now, if we have different databases, and those databases are ready, but that data readiness may not be data availability. So a database in Panchayati Raj department, if it does not talk to another database, and if those formats are not standard, and if the APIs are not, is as good as two different data, and they don't talk to each other. So the second part, around security. Right now, I think we're talking about security of systems. But the moment we talk about deep tech, there is this whole perspective around, I'm trying to now, my threat vector is across the systems. My threat vector is also around data, and my threat vector is also around decisions. Now, as deep tech gets adopted in different systems, one thing becomes critical is, if one part of the system starts failing, it's not just a failure of that system itself. The risk would actually transfer to the ecosystem. For example, there is a chatbot. There is a certain department, it is running a chatbot, and the chatbot starts giving out certain erroneous results. Now, if there are citizens who are accessing those results, they would start processing whatever that output is into certain decisions. If there are businesses who use that data output, they would start using that into certain decisions. So it is not just limited to that particular system, but it also translates into the ecosystem. So I think those are the nuances that we need to keep into perspective as we are looking at adopting deep tech into governance systems. Thank you.
So trust, in openness, interoperability, and don't think about deep tech as a layer. It requires a fundamental reimagination of your workflows. And I think that's the perfect segue for Dr. Santosh Mishra. He's the partner at PwC. He's been on the e-governance side as head of the Tamil Nadu e-governance agency. He's been an IS officer for 20 plus years and then moved on to the other side. So he's seen what actual implementation looks like, and now is looking at saying, how do you make that happen? So Dr. Mishra, maybe if you could could talk about, particularly from a governance, AI-led governance or citizen-led governance, digital transformation, what have you seen and what are the real changes that are needed as deep tech becomes much more critical?
Thank you, Sangeeta ji. I think, I have been seeing this from both sides of the window. And I think what I have seen over the years, and I think, and it was quite evident in the morning sessions as well, government has got its act together. I think that's something very, very important. And they have identified the areas where the focus needs to be. And I think what has recently transformed, and I think this was kind of referred to in the morning session as well, we believe that knowledge is without boundaries. And I think knowledge everywhere is available to everyone. I mean, that was a fundamental principle behind internet revolution, which actually transformed a lot of lives in this country as well. However, as things have progressed, and as we have seen in the recent past, knowledge is getting gatekept. So, fable or mythos or export controls, data controls. I think the first one was GDPR. So that is coming in, and I think what new dimensions of, while all the progress on AI and of course the 7 pillars of data, compute, etc., were there, what is the new dimension which has been added is the sovereignty. And I think that's something which all of us, I think, collectively need to start looking at and think about. As we interact with a lot of governments, and I work with almost a large number of state government, central government, I see that this is becoming a very high point of concern in everybody's mind, and especially in the policymakers' mind. How do we handle the sovereignty angle? Is this available knowledge will remain available to me tomorrow? How's the token economics going to work for me? Am I actually paying free? And this I have been saying even before these chat GPTs and AI had come into the field. We think that we are getting the services for free, but they are not for free. We pay by our data. And I think nobody can generate more diverse, more richer set of data than this country we have. So I think we have to worry about, and when we say about sovereignty, when we talk about sovereignty, it's not about model. It's about data, and data that runs on a model, and that model that runs on a hardware, and that hardware is powered by the power grid. Thankfully, on the power side, hopefully we are better off. I'm told in US it takes about a year to, if you want to set up a data center, to get the power connections, it takes about a year because the grid is not geared towards sanctioning that kind of load. In fact, one of my friends who runs a company and that basically does this, finds out hidden inefficiencies in the grid and actually makes the power available to a new data center. And I think that's a big business he's running. So coming back to the story, so I think the sovereignty has multiple layers, starting from data, starting from, and thankfully we have now India Semiconductor Mission as well. While I don't think we are there yet to produce 2 and 5 and 7 nanometer nodes, but at least it's a great beginning. It's a right beginning. 48 nanometer node is good enough for most of our appliances, automotives, etc. And slowly, hopefully, with this coming in, hopefully the innovation will take its own course. So, I think we have to really get our act together, and I'm so happy that Ritu was mentioning. They have small language models which work terrific. We have Bhashini, which again is homegrown, works wonderful, and voice is the future for this for public service delivery, for citizen interaction, for governance, and another trend which I have seen, and I think that is a realization which each state government has come to a conclusion on, is to have a family-oriented state family database, so that they can actually deliver services proactively without a citizen coming and knocking at the doors, and also keep track of beneficiaries. One of the state governments we were working with, they gave us some sample data. A scheme which is meant for women, I think we found some in the sample data about 5% beneficiaries were males. So either the data is wrong or there is a problem. So I think getting all that act together, putting data in a family-oriented way, structuring it, sharing the data, preparing it for the AI, and then having our own models work on it. I think we are far off having our own processors work on it. I think these are all step-by-step changes which hopefully will come. And that's the way forward I see in this space.
So clearly sovereignty is an important focus, and we couldn't agree more, right? I think with everything that's happening where technology, geopolitics, business is all coming together, I think every country needs to figure out where will it partner, where will it build, and where will it govern, right? So I think that's a very important layer. I'm going to do one set of questions more and then come to the audience and ask any of you if you'd like to ask questions. So please do, think through what questions you would like to ask. We really want this session to be as engaging as possible. Ritu, if I can come back to you, right? We've talked a lot about what is already happening, but there are lots of constraints or potentially opportunities that could be out there that we are not tapping to the full. When you were thinking about building a voice AI company in India, how did you think about data? How did you, and given the diversity of voice data in India, what were the things you did to make this truly reflective of, the accuracy that is needed for all of this?
Great question, Sangeeta. And, as we're a very diverse country, right? And even when we speak, we don't speak in one language. If my son has to say that, wash my jeans, the way he will construct it that, Ma, jeans dirty hai, aaj, are you going to wash? So Hindi, English, right? All of those things kind of combine together. Now imagine this is how we speak as a country. When we are talking about large enterprise customers, it's this level of complexity with language, and this is, I'm only talking about Hindi and English. This is how Marathi and English goes. This is how Tamil and English goes, right? Some things don't change, like form or numbers. They still remain the same. Now you include multiple decision trees with it, right? So if you're talking to a very large enterprise, which is like a few billion-dollar company, we're talking about 20, 30, 40,000 decision trees that are within there. Something Parminder touched upon as well was, we often go into companies wherein if there's an AI agent and if that agent is representing the company, and imagine that agent has promised a refund on company's behalf, you are liable for that, right? So how do you make sure that whatever is the agent or the voice agent saying is accurate, has backing to it, and so on and so forth? So when we do all these large scale developments, those are the real nuances that we have to look at. The fourth thing is, which is something that we're seeing more and more, that when you're using these models, right? So Claude or ChatGPT and multiple such others, right? So I don't want to name these to name, but a family of these models. The moment you bring scale, it becomes almost unaffordable for a lot of companies. And that's where when you are looking at sovereign models, it is also about making sure that it becomes cost effective, so it can reach multi-million or few billion users. And that's where the problem is. And these are the 5 steps solution that we look at, that whenever you're looking at implementing AI at large scale, it is going to be a mix of complexity of language, making sure that there is right explainability, making sure it's at scale, it's affordable, and so those are the things that we look at, Sangeeta.
So when you're building a SLM, right, for all of these complexities that you talked about, how did you get access to all this data, which is so different from how you will say something versus how I'll say something? So how did you create that contextualization?
So we specialize in building custom models, as I spoke, and I'll give you an example. We work with a very large Japanese conglomerate. They have a plan called Saikyo plan. Saikyo plan in Japanese is good day. But the current models that exist today, they translate the Japanese Saikyo into Psycho and then translate it back. And that's where the whole context goes for a toss. So mostly when we work on these large projects and, we actually do get access to data where we train these custom models on their proper nouns. I'll give you another example. Uber Black. That's a service. Black is not a color in this case. So how do you make sure that Uber Black, with its different kinds of price plans, multiple cities, etc., when it comes together? So the idea is to build a custom small model for these companies that can work on phone, that can work on premise, on edge, etc. So that's how we get access to the data.
This is very focused on the enterprise, on the user and their data. And I think, Ravi, that's really the question for you also on, in the enterprise world, we've seen so many of these deep technologies coming up, right? And it started with AI analytics, pre-Gen AI world, then there was Gen AI, then there was agentic AI, now there's physical AI, quantum computing, cryptography. I think there's just a lot of different deep technologies that are becoming much more mainstream than in the past. The evolution curve of these has shortened a lot. So in the enterprise world, how do you navigate all these technologies? And, are there any reflections for, the government stakeholders who are in this conference on how should they be thinking about it from, some things you may have done well?
Thank you. That is a very tough question. And we break our heads every day on that. Especially, right, like I don't know whether you all noticed or not, in the past 7-8 years, the speed with which the technology is evolving is mind-boggling. And every day, right, like we look at, hey, right, like we have a new version of the model, or right, like we have a new version of technology, it is already obsolete, right? So with that, I think the way that we are looking at is in 3 dimensions. So the first dimension is having a consistent migration strategy. So that means, right, like again, we keep, right, like a target state at a conceptual level, right, like in mind. And we know, right, like we never reach the target state because the target states keep moving. But right, like we will be moving towards the target state, right? So the target state, so the migration strategy essentially is, right, like not just one technology, but an integrations between these technologies. Because, right, like by the moment I look at AI, something changed in cryptography. By the time I looked at like cryptography, something changed in the infrastructure. By the time I looked at infrastructure, something changed in databases. So these things, the technologies keep changing. So we always need to keep the integrations in mind and, right, like make our migration strategies, keeping, right, like the integration migration strategy in mind. Now, the most important thing, right, like in all this is keeping skills and upskilling people, right? So when I talk about skills, the skills are not, again, right, like about a particular technology, but look at a domain capability and upskill people in the domain capability. So that means, right, like you may have to have a person who can talk the AI technology, who can talk the DLT technologies, who can talk the database technologies, but, right, like how they relate to a capability. For example, right, giving a consumer loan may be a capability. So how do you use and stitch these technologies together to meet that capability? So these are the 3 dimensions. So that are internal to the organization. But then external to the organization, you have like so many external forces that are coming in that actually can force your prioritization of your roadmaps or migration strategy. So for example, like again, when Mythos came, so suddenly, right, like all of a sudden, most of our migration strategies around we need to take a step back and say, hey, right, like, okay, what does it mean from a vulnerability standpoint? And how quickly are we able to fix our vulnerabilities, right? So again, external factors is again something that we always need to keep in mind that can influence our migration strategy. So that is how we try to look at it.
So think of what you need from an internal perspective, which is clearly context, domain, skilling your team, obviously managing the risks, and of course, external environment is far harder to navigate, which I think a lot of the people in the room really focus on. Dina, if I can come to you, right? Again, from a quantum perspective, particularly stuff like, quantum security and, the ups and downs of what you see in the quantum world, what are the use cases that you can detail a little more that will make this technology more real? Also talk a little bit about the work you're doing in Andhra Pradesh with the Quantum Valley.
Okay. I think I'll first start with the use cases. So broadly, we expect quantum computing to be promising in, say, 4 kinds of computational problems at a high level. The first one is in simulating nature processes, let's say something about studying properties of molecules or biological systems and so on, or in chemicals. So that's sort of the first pillar of applications where we see. The second one is more around optimization problems. I think like I mentioned when I talked last, these two, something we expect advantages in the near term. We'll probably have some announcements later this year which show like how quantum computing based solutions do better than any like computing that's leveraged to solve the same problem. Something that we'll see in the longer term, but equally promising, and we expect the power of them are in solving some classes of machine learning tasks, because quantum computers do operate over this sort of, if I go technical, it's called this exponential space. It's called the Hilbert space. So there is an opportunity to expand or exploit more of that theoretical power in trying to come up with new kinds of models that hopefully can better, let's say, like pick out patterns as one of the possibilities. And then we also expect promise in solving partial differential equations. Okay, so I talked about the computational problems. So which kind of industries that each of these are? The first one, solving nature processes predominantly in pharma, chemicals, and also like aeronautics and automobile industries. Like for example, in studying new properties for batteries or studying the materials that have to be going to the next generation aircrafts. And like I said, new vaccines or new chemical, like mining extraction processes to better, like had better value added products from mines, right? So that's the first one. Second one is optimization. It can be in logistics optimization. It can be in some time series forecasting style work, or I think like large vehicle routing network. So those are sort of some of the examples of where in optimization, so you can naturally see it applied across industries like in like logistics, manufacturing, and so on and so forth. And then third, in terms of learning, for example, like finding needle in a haystack kind of problems. So we have like huge data sets and trying to find anomalies. It can be in fraud detection, like in financial sectors, or it could be like sort of the space and scientific data, right, that we collect petabytes of, and we try to study the existence of new particles that are in space, and so on and so forth, right? So that's the third type. And fourth thing, solving partial differential equations. That's extremely useful for strategic sectors like defense and aeronautics and automobiles, because those are the type of computational problems that we design and modeling, let's say, weather or like I said defense because that's how you study like how, like let's say like the path of the projectiles, or these are the kind of computational problems that have to be solved in solving many of these high energy, like heavy engineering systems. Okay, so these 4 kinds of computational problems have wide applications across domains, and the initial things that I mentioned are we expect in the near term and in the long term. The later ones in the long term, like 5-ish years. So now that I've covered the different applications that are possible or that we are already exploring, I mean, these are not something I'm sort of saying from theoretical basis. All these applications that I mentioned are something we have already collaborated with the leading industries in those specific sectors. And for each of the ones that I mentioned, there are already like research papers and POCs that are done. Okay. Now, what do we do in India? And what do we do in Amaravati Quantum Valley, or what's coming up in Amaravati Quantum Valley? In India, there is this ambitious national quantum mission, which has been running for a couple of years right now. And we at IBM work very closely with them, or try to sort of support them in terms of technologies, at least provide a perspective, and work with different researchers in shaping some of those proposals. So National Quantum Mission invests in technologies where there won't be organic growth for India without a government intervention, but it has to be done on technologies where it's really needed. For example, in building new types of computers, right? So building new quantum computers and then establishing quantum communication networks, discovering new quantum materials, and so on and so forth. So these are the main aspects that Quantum Mission invests in, from sort of starting from R&D to startups and getting them to the real world, right? In Amaravati Quantum Valley, the Chief Minister of AP has had an ambitious plan. He's building a new capital, so he might have gone safe with how he invests in building up the city. But he has this ambitious plan of starting with deep technologies like quantum computing, right? And then having a larger ecosystem around that in terms of applications across domains. So concretely, we are bringing a state-of-art quantum computer, one of the best available in the world, to India, to Amaravati Quantum Valley by the end of this year. Okay, it will be 156-qubit machine from our IBM's latest generation of quantum computers that's coming into Amaravati. And we have a planned set of activities in getting the ecosystem developed towards making the best use of the computer that's coming in. Okay, starting with deep tech enablement, to understanding where the quantum computers can be used and which industries and domains can benefit from it. And AP has this sort of 100 use cases that they want to demonstrate from AP ecosystem, leveraging these quantum computers. Partner with multiple industries and startups to deliver that. So we provide we are an active partner in sort of coming up with potential use cases and also getting the ecosystem developed to realizing them on real quantum computers.
Thank you so much, Dina. Santosh, if I can move to you, you work with a lot of different states in India, and as you hear the panel, we're talking about voice AI, we're talking about digital trust, we're talking about quantum. Is there a playbook for states that they can think through on how do you implement these deep technologies? How do you choose what to do? Because everyone is, there's a hype, and then you start going into that hype without really thinking about what is the problem that you're trying to solve. But is there a standard playbook, or India is too diversified to really standardize things?
Extremely important, and I think this is one of the potential pitfalls of this whole hype. what happens is that because states are also competing with each other, not only in terms of purely in terms of investment or attracting investment, but also in the public perception, saying that we are also doing this, we are also doing this, we are doing the best of the technology, bringing the best of the technology to their constituency and the voters. So the pitfalls are that if you actually start doing things, and I have seen it in few states, I would not like to name them, they want to do get on the bandwagon and say that, oh, we have this thing in AI and this is what we did in blockchain and this is what. I think the most important thing for the states, and I think you talked about playbook, and possibly Government of India or somebody needs to sort of help them, guide them, DIC or NCeG, one of them, saying that first identify the need. I think instead of starting from saying that I need to be on this platform, identify whether that is the right platform. And I think, and this is particularly true with Web3 technologies and blockchain. And I think there was so much of hype which came along with them, and many state governments and many governments started to jump on it and saying that we will implement. Identify whether there is a genuine need. Is this going to solve a real problem? If it is going to solve a real problem, then only we should actually invest and take that technology forward. And then once we have invested, then the other problem I have seen in governments, Sangeeta ji, is that they start off with a lot of hype, lot of excitement, but halfway there, either there is a change in the leadership or there is a change in the ruling dispensation, and the project which was halfway there is suddenly dropped and it dies its own death. So I think that's one folly we should all avoid, and this is something which I would like to attract the attention of the policymakers. Make sure that you get on to the right technology platform, start investing into them, then take it to the logical conclusion. Don't leave it halfway, and actually have the capability to actually continue, because these technologies and most of the deep tech technologies are so rapidly changing. And in the field of AI, as Dr. Ravi was saying, I mean, every day there is a new model which comes up. I mean, GLM 5.0 and then GLM 5.2, and then something comes up as an open source, and you can't keep track of it. And if you invest into a technology, then make sure that you have an institutional mechanism to keep you continuously updated on that. If Andhra Pradesh is doing Amravati Valley, and I'm so glad, in fact, I've been to Andhra Pradesh and I have witnessed what they have done in their quantum reference center and all that. At least they have created an institutional mechanism to continuously upgrade their skills and ability to have that ability to draw benefits out of the investment they are going to make. And this is again something, as a former policymaker, I would advise caution to the government, saying that please focus on 2, 3, whatever is critical for your state, what makes sense for you, what is affordable, and what is sustainable for you in terms of technology upgrades and ability to extract the full juice out of it. So that's something I would like to highlight.
No, very, very practical inputs, right? Think through what you're trying to solve. And Parminder, this brings me back to the question you were talking about, right? Readiness, scale, risk management, yet keeping it open, inclusive, and trusted. I mean, those are good things to do, but how do you make that real in practice? Yeah, especially if you're at the government public sector side.
Sure. Absolutely. I think if you look at it, the workforce readiness is a key component. When we talk about deep tech, AI, and I think if you look at most of the systems, it's less about. Technology readiness is a key part, but the people readiness part is a very important part. In fact, if you're really interested in the people readiness part as to how important it is, we've recently published a people readiness report. If you just type people readiness report Kyndryl on Google, it'll be the first result. We just published it last week. And what we are looking at is different organizations have these people readiness challenges. But I think I'm very enthusiastic about it also. We recently published 2 courses, on Karma Yogi, and this was around how to use AI in governance, how to use decisions in government using AI, how to inculcate using AI. We said, okay, fair enough, let's create these courses. But then the learning week happened, and the kind of feedback that we got was phenomenal. I mean, there's some 70 lakh government officials who enrolled in those courses. I mean, the total universe, I don't know, it's about 1.5 crore, but 70 lakh officials, they were interested in using these frontier technologies. I mean, it says a lot about how much people are interested in trying out and in learning new systems. So I think there are 3 approaches to it. One is we got to democratize deep tech, frontier technologies, access, and democratize learning, what it means. It doesn't mean that one needs to know how to develop new systems, but essentially how to use those systems who are using some of these technologies. I think that's one. Second is, I think I want to just maybe rewind 5 years back. The kind of teams that we used to have, these were cross-functional teams. If we had architects in the same team, we had technology people in the same team, we had operations people in the same team, and there was a lot of cross-learning that was happening between the teams. As we go into frontier technology, so it's not just about technology, it is domain, it is operations, it is architecture. So cross-functional teams, I think in organizations, rather than having technology teams doing work, in one part of the office and operations team, I think we've got to have a lot of cross-functional teams. I think that's second. And the third is, rather than having separate trainings, I think it's about on a job role basis. How do you take decisions? How do you have decision augmentation using some of these technologies? I think moving forward, we're going to see not a very, specific capacity building, but as in your daily job role, the way you're doing your jobs, a lot more capacity, a lot more awareness building into how to use these technologies, how to augment your decisions, how to look at some of your colleagues, how they're using these technologies. That is what builds in capability in the teams.
Wonderful. So people readiness and, don't create silos, right? There is no deep tech team within a department or a company. It's a lot more cross-functional collaboration that's really needed. Any questions in the audience before? Otherwise, I have a set of questions I'd like to ask, but love to see if there are any questions that the audience wants to ask our panelists. Anybody? Okay, there's some questions here. Why don't you come? Why don't you just speak up? I think they're taking a mic.
Hello. It was a wonderful session where we got to know about tech, policy, quantum thing. My name is Khushi Johri and I'm the founder of SFK, Sustainable Finance with Khushi. As you guys shed light on both the policy and the business aspect of AI and quantum and how sovereignty and accessibility are aspects of it, how do you think is AI adding to the polycrisis of India, where 25% of India's population does not have access to safe water, and putting up AI data centers or maybe quantum and other such techniques in already India has a huge water crisis, and with the growing population, it is only going to increase. So I get it that having own data centers is important, but don't you think making water available to the country's population is equally important? How is India going to balance out these things? Please shed the light on it.
I think it's a very important question you raised, that on one hand, we have the sovereignty implications. We need data centers in India. We need to build the AI infrastructure for AI innovation to happen. And how do you do that sustainably, both from a green energy as well as from a water perspective? So maybe Parminder and Dr. Mishra, if I can come to you, it'll be great to get your perspectives.
No, I think it's the same old debate which we had always. I mean, we didn't have enough food to eat and we had a space program, right? I mean, so I think you have to, I mean, it's just like our home. I mean, so we have to cater for every aspect of life. I mean, so we are living in a world where we have to take care of technology. Today's technology is not only a fancy thing. It's actually a strategic asset. I mean, it's as, I mean, मुझे याद है वो IIM में मेरा एक बार वो ग्रुप डिस्कशन में इंटरव्यू में उन्होंने टॉपिक दिया, आर्मी को रखना बॉर्डर पे जरूरी है कि खेती करने के लिए इन्वेस्टमेंट करना जरूरी. I think both. I think we have to do both. We have to manage our water resources well. Unfortunately, today we kind of overly we were focused on AI and quantum for obvious reasons, because these are something which is right there knocking at the doors. But when we talk about deep tech, there is much more to that. I think climate technology, managing water is also a very, very important deep tech work actually, which we need to do. We need to work on, material designs. I mean, you look at jet engines. We don't manufacture jet engines. And one of the reasons we don't manufacture jet engines is because the blades which run in the jet engine have to run at a higher temperature than their melting point for 16 hours at a go. So, I mean, there are a lot of aspects to deep tech, apart from just the AI and the quantum, and water, sustainability, climate change, carbon capture. All this is part of that spectrum. And I think we need to invest on all those. I mean, if we want to be a leader, we are a democratic country. We have a huge, technically qualified human resource, and we have enough talent, thankfully enough, capability to invest in all of those and actually take the country forward. There is no other option. So it's not A versus B. It is we have to do A and we have to do B.
Just to, I think, add to that, I have a slightly, nuanced perspective to that. I think as a country, we can live by a lot of constraints, saying, okay, fair enough, air pollution, big deal. I mean, development is important, and fair enough, water scarcity. But I think we are reaching a point where, some of these strategic assets will need a continuous access to water, for instance. Energy, for instance, most of the energy that gets produced in the nation is coal-fired. So I think those are questions which will now, which were somewhere in the back of the mind, but with the right set of amplification through technology now itself, I think on a grid we can clearly see, look, what is the impact that is getting generated. If it's the competition for water for crops versus data center versus potable water versus water for industrial use, and hence so far a lot of planning was happening. There's a lot of assumption in planning as well, but I think a lot of it will come in the fore because some of these resources are not unlimited for us. I think moving forward, sustainability is going to be very, very important moving forward. If you talk about, now that's where I think some of these frontier technologies will also be used to solve some of those challenges. For instance, most of the workloads today, we're talking about frontier technologies, most of the workloads, they don't need access to very advanced platforms. They don't. In fact, more than 99% of the workloads, they don't need very frontier technology infrastructure to solve. But right now, we don't have a policy as to how to classify different workloads. There are times in the day where green energy is available. That's a time maybe we look at segregating workloads and processing those workloads. There are times in the day where we don't have access to green energy. So what do we do those workloads? So prioritizing those workloads. So I think those are questions that will come to the fore, and those are the problems that technology will help solve.
I have a question, please.
Sarita.
So it was a wonderful session indeed, and very comprehensive. We had a lot of food for thought also, some warnings, some, the ways forward. My question therefore is like looking 5 to 10 years ahead, which areas do you think from your work areas or knowledge will be making good impact, with the use of deep tech areas, which will make great impact in the country? Number one. And two, the skilling that the next generation would be looking at to adopt these technologies.
I think that's a phenomenal question, Saritaji. Maybe, Dina, we can start with you and, then we'll go across.
The technologies that we are discussing today as deep tech like AI and quantum computing and so on will certainly remain and actually even more deeply immersed in enhancing both the day-to-day activities and in sort of nation level, large scale or enterprise level, let's say productivity and more strategically like integrated, right? So that's going to happen for sure. We might have something new come up, but what we have always seen is that science like evolves at a linear pace. There is like rarely a major breakthrough that makes it from totally impractical to, like now we can widely deploy it. There's a linear pace. It's just that at some point, some advancement happens beyond a threshold that it catches all our attention and we start deploying it or like attempts to commercialize it and so on. So that way, I think there are multiple scientific explorations that are going on across technologies, and I think we can only speak for the ones that have surfaced, and these will certainly see wider adoption, and will probably every 5 or so years we can expect some new breakthroughs and new technologies coming up, and I think we'll have to keep up as a country and try to apply it across domains.
Yeah, please.
So, I mean, I have already spoken enough. I shouldn't be, but I couldn't resist. So I think the going forward, the technologies which will impact us in a significant way is kind of already discovered. And because we are such a software, savvy nation, and I think Sangeeta ji will agree with me that so AI is going to stick with us. So is quantum computing. But I think, in my opinion and limited understanding, is one of the technologies which is going to really make a difference between the winner and a laggard is going to be materials. And I think that's in my opinion, that's where I think we as a nation would want to invest heavily. The second point was skills. I was just quoting to him or her, I think. I was just watching Elon Musk's interview, and somebody asked what is the skill they should teach to their son or a daughter. And he said unequivocally physics. So I think maths and physics are the skills of the future. If you look at the entire AI construct or quantum computing construct, it's pure maths and physics. The new models which are being discovered, the new methods so you move from recurring neural network to a transformer architecture, that made a huge difference in how your speed up of your, tokens started. That is based on pure maths. How do you do low rank adaptation? How do you reduce your compute footprint to generate the same amount of token output? I mean, so it's all, I think we as a nation need to, I mean, I'm not for a moment suggesting a de-emphasis on the finer aspects of life, which is fine arts and psychologies and all. But I think the innovation, the scientific innovation, which is going to make a large impact, is going to come from physics and maths. And I think as part of India AI mission, we should have a maths grant as well.
Yeah, I think that's very well said, that, don't only focus on being a computer science engineer. I think you need the core fundamentals. And I think we can see Ravi wanting to comment. So Ravi, if we can go to you.
Yeah, I think I 100% agree with materials. So materials definitely is going to play a long and very important role. And the other thing is around sustainable technologies. I think that like almost every government like in the world has signed some kind of sustainable treaty, right? So again, like how do we achieve those targets? Right. So there is going to be a lot of emphasis on sustainable technologies, whether it be water technologies, whether it be cooling related technologies or whatnot. There is going to be a lot of emphasis, at least like in the next 5 days on that, and next 5 years on that. Then the third is some of the technologies that we are using today, they will translate to newer technologies. So for example, all the data technologies that we are using, in my mind, that we will transform from data to knowledge, right? So that is going to be like another huge shift in the way that we look at data. You have to have explainable data, explainable policies to get to explainable knowledge. Then that gets consumed by AI, right? So the more and more like you make your knowledge explainable and have operators and rules around it, again, mathematical foundations, but like that is very important.
So maybe for Ritu and Parminder, right, as you are hiring these young college grads coming out of colleges today, what are the skills that you are looking for? And, it's not that these skills will stay what they are, right? And to the question that was asked, how do we ensure that there is a continuous skill readiness to what is the technology shifts that are underway?
So I would completely agree with what he just said. The way computer science is changing, there is a new model every day. There's a new technology every day, right? From Python to something else. But fundamentals don't change. Physics and maths don't change. Statistics don't change. So we mostly hire, grads with maths or physics as the background, and in some cases, computer science as well. But let me paint a picture, right? And going back to your question, and I was thinking about it. Even today, large part of our interactions happen through typing and forms that are in Hindi, English, right? If a person in rural India, a woman wants to open a bank account, you cannot imagine the friction that person may have to go through, right? Just by saying, can I open a bank account, and that on the other side, somebody is asking the right questions, and just by saying those answers, the form gets filled, gets there. Huge. Second piece, so this is finance I'm talking about, financial sector. And the healthcare sector, same thing. There are so many women, and we'll be surprised to know that even in tier 2, tier 3 cities, there are women who do not have access to healthcare system and the right kind of doctors. Imagine if they are able to interact with state-run programs that actually gives healthcare, which is preclinical, subclinical support in the language those people are talking. It is going to be game-changing, right? So that's how I see the implications of technology. And I see that everybody will have access to technology, not just people who know read, write, or sometimes just family biases, family construct that may prohibit them, but that will be available. So just to answer both questions, Sangeeta.
I think very important a question that you kind of raised. So one part is absolutely physics and maths. But what about the rest of the population who are non-science? I think it's not that grim. If you look at the state of technology right now, state of systems, I think the move that is going to shift in the next 5 years, for sure, is Right now, there is a lot of record crunching that's happening. A lot of time is spent in record crunching, information maintaining, pulling information, storing information. I think we are moving to a stage where rather than reactive governance, gradually we're going to move towards predictive governance. How does that look on the ground? Right now, there's a lot of, let's say, IoTs which are being, we are able to monitor weather. We are able to monitor rainfall. We are able to monitor temperature. I think what the kind of systems now that are going to be built moving forward is, look, if this is what is the weather pattern, this crop is definitely going to fail. And hence, if this crop is going to fail, then let's look at the problem statement of what crop we should look at, especially if this is the weather prediction. It's, moving forward, we're going to have a lot of hyper personalization. So right now, everybody has, let's say, the same tax, when we are filing tax, the same interface for income tax portal. Moving forward, depend if you are, if you're somebody who, for a lot of us in the room, we have a very different view of economy. We have on 30th, everybody's accounts, or first we get a SMS saying, look, okay, so-and-so salary is there. I mean, for 99% of India, it's not like that. A lot of products, which are right now EMI based. I mean, it's only for a very, very small percentage of population which have an EMI based structure. If you look at 99% of India, they don't have a financial structure which can support an EMI based financial economy. So I think moving forward, there's going to be a lot more hyper personalization. So there's going to be a lot of creativity which is also going to be generated. People are going to, if you look at Gen Z, one great thing I look at Gen Z is, from at least, I can talk about myself. I still have my focus on, look, let me focus on records. These three things are tech, my day is good. Gen Z doesn't behave like that. They are a lot into experience. What is the experience of day I have? If I'm going and, let's say, going into a job, is it fulfilling for me? What's the creative part that I'm doing? So I think as human beings are also evolving. So I see, that these are some of the shifts that are going to happen moving forward.
I know with that we are out of time, but Saritaji, clearly skilling has to be agenda number one for India, given our demographics, given our population. And it's not just about skilling for technology. I think it's about learning to use technology for every task that you do, whether you're a plumber or a driver or a carpenter. How can I leverage AI technologies or many new technologies that will come in to deliver what is needed? In fact, I think I was hearing a podcast yesterday where somebody was saying if all these data centers are coming up, I'd rather not be an AI engineer, but become an HVAC engineer, because that is the future that, where the most high paying jobs will be. So I think we are in a world where we are going to see a lot new opportunities, and the mindset of learning has to be continuous. It's not something that you can do once and say, I finished my graduation, post-graduation, and that's the end. So thank you all for staying here. I know we are between you and the cultural evening, but thank you all for attending the session. I hope you enjoyed it. Some of us are around, love to get any further feedback or inputs as we look forward. Thank you. Thank you to all my panelists. Yeah.
Thank you very much, ma'am. I think that skill for everything is very relatable, because even to manage a house today, you have at least 5 different apps on your phone, whether it is your groceries, whether it is calling a vendor, or of course the UPI app. So there are multiple apps. You need to be technologically skilled for that. So thank you so much for sharing that from this stage. And for now, we have the memento presentation ceremony, for which I would be inviting Shri Ajit Kumar Shah, Director DARPG, to join us on stage so we can present these tokens of remembrance of the NCEG to each one of our panelists, our experts, our moderator. We'd like to present the memento to Ms. Sangeeta Gupta, Senior Vice President, NASSCOM. Put your hands together, everyone, as we felicitate her on the stage of NCEG. Shri Parminder Kakria, sir. Thank you for joining us. For the next memento, I'd like to request Ms. Ritu Mehrotra to kindly accept the NCeG memento. Shri Santosh Mishra. Shri Ravi Kappagantu. Kindly welcome each one of our experts and let's show our appreciation through the sound of the audience claps. Dr. Dhinakaran. Yes, everyone, each one of our experts have shared their lifetime of insights and made this plenary session very, very valuable. I would like to request our experts to kindly step forward for a group photograph. And I would like to inform you all that after this plenary session, we have the cultural evening. Thank you, Mr. Shah. We have the cultural evening and you do not want to miss that. It is beautiful cultural representation. It is something that would stay with you forever. Such talented group. For this cultural evening, Anita Pradhan Group will be taking over the main auditorium and the anchoring will be done by Pranay Bhardwaj. I would also like to share with you that tomorrow we have 3 more plenary sessions and after that post lunch we have the awards. So I will see you tomorrow in the morning as well for more insights, more deliberation, more great ideas being platformed at the National Conference on E-Governance 2026. For now, I request you all to stay seated as we prepare the main auditorium and transform it into a cultural and absolutely memorable stage for everyone who is here with us.